Today I'm going to show you how to measure roller chain for wear elongation. First, let's learn the components so we're all speaking the same language. When I'm talking chain, roller link, pin link, roller link, pin link. The roller link's the narrow link. So if you break that chain apart, this would be a roller link, consisting of a roller, a bushing, and a side plate. And this would be a pin link. So a pin link connects a series of roller links together. Roller diameter. This is the roller that engages the sprocket. Inside width. I'm talking the inside width of the roller link because that's where your sprocket goes. Pin diameter. Pin length. That'd be this distance right here. Link plate. You need link plate thickness and height. And last thing and most important is the pitch. Pitch is the distance from pin center to pin center. It's hard to measure the pitch in the field because you're trying to go from pin center to pin center. So what I like to do, I prefer to use a digital caliper, and I like to measure from outside a pin to outside a pin. Okay, provided the pin has a nice edge on it. You don't want it peened over or rust on it. You want a nice clean edge. You want to measure outside to outside and then subtract the pin diameter from it. And that'll give you the same thing as measuring from the center of pin to center of pin. Once you have the chain measured, compare it to the catalog to determine the size. Some chain will have a number stamped on the side plate. For instance, this one says 100. So I know this is 100 chain. Now know your chain size. So now let's discuss wear. What is wear? Wear occurs when the chain articulates, bends, around a sprocket while under load. As the ID of the bushing and the OD of the pin wears as it articulates, it causes the chain to grow in length or elongate. So what I'm referring to is roller link, pin link. As this pin rotates inside that bushing, over time it causes wear and the chain will elongate. If the chain elongates too much, the chain won't engage with the sprocket correctly and you could have severe downtime. After you know your chain size, look at the machine and determine if it has a chain take-up or if it has a fixed center. That'll determine which side of this elongation ruler you will use, and I'll get into that in a little bit. I have a demo rig set up that I'll use for an example. If it has a take-up, which means the chain can be tightened, we recommend replacing the chain when it has elongated 3%. So what I mean by that is typically the bearings will be slotted to where you can move your sprockets back and forth, or they'll have some type of mechanical take-up that'll keep the chain tight. If it has fixed centers, which means the chain cannot be tightened, we recommend replacing the chain when it's elongated 1.5%. And I'll show you how to measure all that in a minute. These percents are what we call a rule of thumb, so your equipment may be different. Remember, make sure the machine is turned off and locked out and tagged out before you take any measurements. Ideally, it is best to remove the chain from the system and put a predetermined amount of load on it and then measure the pitch. Remember, pitch is center pin to center pin, but very few people have time to do that. Most will need to measure the chain while it's still in the equipment. You will always want to take your measurements from the tight side of the chain, which is typically right before the drive sprocket. So in this example, if this is your drive sprocket and the chain is moving this direction, as you see, the chain is tight on the top side. The bottom side, we consider the loose side. A quick disclaimer, the elongation gauge I'll be using is just for quick reference. It's always best to measure as many pitches as you can with a tape measure. What I prefer to do is take a tape measure on the beginning edge of the pin, then measure as long as you can, as many pitches as possible, to a corresponding pin to the beginning of another pin, write down that dimension, and then divide it by the number of pitches. That way you have a good average. I also like to take the equipment, measure it, rotate it by a third, measure it again, rotate it by a third, and measure it again. And I take the average of those three measurements. That way you have a good example of the full length of the chain. The chain I'm measuring is number 50. We already determined the demo unit has slotted bearings, which means it's adjustable, which means we can use the 3% max elongation part of the ruler. The 1.5% max elongation is for fixed centers, because you can't let the chain elongate as much because there's no adjustability, because it could cause sprocket to chain interaction issues. If you look over here at our diagram, we show where to connect it. So here we're connecting to a pin link. Remember, make sure your chain's tight. This demo unit's kind of hard because there's no brake in the system. And even on your own piece of equipment, you may need help making sure the chain is tight. So remember, you want to count 15 pitches for number 50 chain. So remember, a pitch is from center pin to center pin, right? So that's 1 pitch, 2 pitch, 3 pitch, 4 pitch, 5 pitch, 6 pitch, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's the 15th pitch. Chain's pulled tight. You'll see that the edge of that pin is not to the 50 line, which means there's a lot of life left in that chain. Once the edge of that pin reaches that 50 line, the chain will need replaced.